Okay, so we have set up the table ready to start. So I'll just explain what we've got. Here is the graph with the start node A and the destination node G. Underneath it are the heuristic values being the educated guess of the distance from each node to the destination node. So notice that going out from the destination node, the distances get bigger. So the estimated distance from G to G, that's going to be 0. These F, that's 30, and E is 50. But the further we move out, D is 50 away, B is 80 away from G, C is 65 away, and A, the furthest one, is 90 away from G. Okay, that's the heuristic estimate, the educated estimate. Okay, so here are our tables. We have the node, that's the same as manual Dijkstra. Visited all node neighbors, that's a question, and that's the same as manual Dijkstra. You have the distance, shortest distance to the start node, we're calling G now, and that is also the same as in manual Dijkstra. We have a new column here for the heuristic distance to the destination. Here we have a new column, and it's simply F equals G plus H. So it's this value plus this value, and that's how we work out what this column is. And then this is the same as manual Dijkstra, the previous node. Okay, now filling in, we'd fill in all of the nodes A to G in alphabetical order. These are all the nodes we have. Have we visited all the node neighbors? For A, no. And similarly, that's why we populate n for each of these rows. The shortest distance to the start node, well, A is the start, so we know the distance from A to A is 0. Everything else we don't know yet, so we're going to populate it with just a large value, which we're going to use as infinity. The heuristic, we're given the heuristic in the question, so we can just populate that from the graph. And it's in this question, it's written below each node. Okay, so that's all that is. Okay? And notice that the further you go out from G, the distances get bigger. So we've got 30 for F, 50 for E, and we're getting further until we get at A, the furthest node is 90 away from G. Okay? So that's all populated here from the question. And we can populate the first row here for F because it's simply G plus H. We know the value of G and know the value of H, so we can populate this. The rest, we put the just an arbitrary high value, so we're choosing infinity. Previous node, well, the previous node for A is not applicable, so we just put a dash there. This is our same helper table as in manual Dijkstra, where there's just the node and the node neighbors, which we'll populate as we go. It's just a helper table. Okay, so to begin, just also to remind you while we're here, these helpful arrows, put them on your table because it's just a reminder. If you update this column, you must update this one. If you update this column, you must update this one. It's just a reminder. Okay, so let's start. Now, the question we're asking to decide which is our current node, we say, which row has an n in this column and the smallest value in the F column? So there's only one candidate for that, and that's A. So we put an A here, and then we put our coin at our start, and we say what are the node neighbors of A, and they're only going to be B and C. Now we're going to process each of these to work out this column. Okay, so just like manual Dijkstra. So for B, we need to go to the B row. Okay, what is the distance of B from the start? That's going to be 21, because that is just the distance from there. And we're going to say, just keep it consistent, what's the distance of A from A? Because it's going to be 0, so that's going to be 21. Okay, now is 21 smaller than infinity? Yes, it is, so we update that value. Now, we've updated this column, so we need to update this one. So we go to the same row, and we need to do this calculation. So it's going to be G, which is 21, plus H, which is 80. That's going to be 101. Now that 101 is smaller than infinity, so similarly we update that. Now, this is a reminder, we need to update the previous node. Now the previous node for B was A. Okay, we also have it here. So we need to put an A in here. Right, now we processed B in this case here, so we can put a line through it. Now we need to look at C. Okay, so similarly, C is 42 away from A, and the distance of A from A is 0, so we're going to have 42 here. 42 is smaller than infinity, so we cross that out. Now, we also have to update this column. So we do the same thing. So it's simply G plus H, which is going to be 42 plus the H value 65, which will be 107. 107 is smaller than infinity, so we cross that out. And then the previous node is going to be the A. Right, okay, and we finished C, so we can put a line through that. Now, we have actually processed all the node neighbors of A, so we can actually come back here and answer this question and put a yes here. Now we're just going to repeat the same process to find our next current node. What is, which row or node has an n in this column and the smallest value here? Okay, so that's going to be the B node, so we're going to put a B here, and then we now move our coin to B and we say what are the node neighbors of B, and that's going to be an A, a D, and an E. Okay, so now we process each of these. Okay, so A, we've actually visited all the node neighbors of A, which is good news for us because we can be lazy and just put a line through it. We don't need to do anything with that. Okay, D. Right, there's no Y, so we have to do this. So we go to D. So that's going to be 38 plus the distance of B to the start. So that's going to be, we can nick it from this row, which is 21. Okay, so that's going to be 59. Okay. Now we've updated, and because this is smaller than infinity, this is our current shortest distance to the start. Now, because we've updated this row, we must update this one. So it's simply G plus H. So that's going to be 59 plus 50. That's going to be 109. 109 is smaller than the previous value, so we're going to cross that out. We've updated this column, so we must update this one. So our previous node is, for D, our previous node was B, so we put that there. Okay, so we have finished D, so we can cross that out. Now we're looking at E. Okay, so E. Now E does not have a Y, so we need to do it. So that's going to be 40 plus the distance of B to the start, and that's going to be 21. That's going to be, total is going to be 61. And we updated this column. Actually, before that, 61 is smaller than infinity, so we crossed that out. So now we have a shorter distance of E to the start node A. Now we've updated this column, so we must update this one. Okay, and that is simply going to be 61 plus the 50, which will be 111. Okay, 111 is smaller than infinity, so we cross that out. Now we've updated this one, so we must update this one. So the previous node was B. and we have that here as well. So we can put that there. Right, so we now have completed E in terms of the node neighbors, and we looked at all of the neighbors of B, so we can cross this out and put a Y here. Okay, now we're back to our original question. Which row here has an N in here and the smallest value in the F column? Okay, so that here is going to be 107 here. So that's going to be for the C node, so C. So we put our coin here. Right, so now we need to list all of the node neighbors of C's, which is going to be A and D. Right, okay, so processing A, well, we have already processed A, all the neighbors of A. So we can put a line through that. And now we're looking at D. We haven't processed all the neighbors of D, so we need to do that. And look, we're going to, this is a bit different here. We need to work out the distance of D through C on our way back to the start node A. If our value is smaller, then we're going to override it. So let's work it out. So that's going to be 12 plus the 42, which is 54, which is smaller than the 59, so we can override that. Okay, now we updated this column, so we must update this. So that's going to be 54 plus the 50, that's going to be 104. 104 is smaller than the 109, the previous value, so we cross that out. And then we need to look at D, and what was our previous node? Well, we can read it off here as well, and so that's going to be C, so we cross that out and put C. Okay. Right, so we have finished D, so we can put a line through it. Okay, now we are asking that question again. Which row has an N and the smallest value here? I've gone to do something. We finished C, so I need to I'll cross that out and put a Y here. Okay. Now, going back to the question, what row has an N here and the smallest value here? And it's going to be D because of the 104. So we write the D here. We move our coin to D, and we need all the neighbors of D. So that's going to be B, C, and F. Okay, so B. Have we processed B before? Yes, we have. We processed all the neighbors, so we can lazily put a line through that quite legitimately. Have we processed all of the neighbors of C? Yes, we have, so that's good news for us, so we put a line through that. Now, F, we haven't, so we need to work that out. So F going through D is going to be 23 plus the distance of D to the start, and we know that's going to be 54 because we read it off here. 54, and that's going to be 77. We've updated this. Oh, before that, because we've got a smaller value, we can override it. So that's our new shortest distance to the start node A. We've updated this column, so we need to update this. Okay, so that's simply G plus H. So we've got 77 plus the heuristic distance, that's 30, which will give us 107. And then 107 is smaller than infinity, so we put a line through that. That's our new shortest, that's our new distance. Right, now we need to update our previous node for F, and that will be D. Okay? Right, so we have completed everything for F here. So now we ask that, before we ask that question, we need to say, okay, we've now completed all the node neighbors of D, so we change that to a Y. And then we go back to our question. Which row here has an N and also the smallest value? And actually, it's going to be the F. So now we deal with F as our current node next. We move our coin to F and we say, what are our node neighbors of F? And we put them in our table, D and G. Okay. Now, luckily we have processed all the neighbors of D, so we can put a line through that without doing anything. And now G. Well, we haven't processed that, so we need to do this. So the distance of G through the F is going to be 33 plus the F current shortest distance, which is 77, reading it from here. And that's going to be 110. We've updated, because this value is smaller than the previous value, we need to update it. We've updated this column, so we must update this one. So let's work it out. Simply G plus H. G is this value. Is 110 plus the H, which is 0, and that's going to be 110. Right. 110 is smaller than infinity, so that's our new value. And the previous node to G was F, so we can put that here. Okay, now we have completed the looking at F as our current node. We will ask the question again. We're looking for an N in this column and the smallest value of F in this one. That's going to be G. Now, this is our terminating condition. Once we have completed looking at the neighbors of G, we will end the A-star algorithm. That's our terminating condition. Okay, let's get there. Okay, so place our marker or our coin at G, and the neighbors of G are just E and F. Okay, so we go to the E row. There's no Y on it, so we need to complete. We're going to redo a calculation here. So E through G would be 55 plus G to get back to the start, and that's going to be 110, so that's going to be 110, okay, which is 561, or rather 165 even. 165. Now that is not smaller than the 61, so we will not update that value. Okay. Right, so we have completed E. Now we're looking at F. F does have a Y, so we don't need to do anything with that. Now, we have completed G, so that is our terminating condition, as I've said. Okay, so now we can find the shortest path using A-star. Okay, so we start it just like manual Dijkstra. We read it off in exactly the same way. So we pick it up in reverse first. So the shortest path is going to be G to F in reverse, G to F, and then F to D, D to C, C to A. And we're back at the start. And then in reverse, that's going to be A, C, D, F, G. So A, C, D, F, G. That's our shortest path. Okay, now what's the cost? Okay, we can read it off here, and the the cost of the shortest path is going to be 110. Okay, and there we have it. That was the manual process of A-star, the A-star algorithm, which is an enhancement on the Dijkstra. I'm hoping to make a video explaining the differences between Dijkstra and A-star. Okay, hope that helped.